Good morning, children. Welcome to school. This is going to be part 2 of the log properties. This is actually an assignment that I posted on Google Classroom. And if you would like some further tutoring and you want to resubmit that assignment, here are some problems that are on there that I'm working out with you so that you can resubmit and get a better grade. Okay? With that being said, let's go ahead and jump right in. Now, in the previous video, I spoke about log properties that basically turn, for example, the product of two things. So if I say the log of AB, that can also be expressed as a sum. So log of A plus the log of B. Okay, and similarly, if you have the log of A over B, you can express this as a difference. So the log of A minus the log of B, okay? And so those are the two properties of logs that turn a product into a sum and a quotient into a difference, right? Now we spoke about those, but I want to go ahead and basically talk about the third property in that previous video, in which we kind of talked about the nature of the log, right? What is the log? It's essentially just a linear operator, okay? So for example, let's look at this first rule. It's saying that the log of base A of 1 equals 0. Essentially, the reasoning behind it is saying that the base A to the power of 0 equals 1. Okay? So just look at your base and then look at the right side of the equation. What that is saying is that the number A to the power of 0 equals 1. And that is true because anything to the power of 0 is 1. And similarly, if we look at the next line right here, we have the log of base A, the log base A of A equals 1. So that is saying that A to the power of 1 equals A. Now that is true because anything to the power of 1 is itself. Okay? And you have that exponential reasoning right here. Similarly, as the more generalized statement is saying that A to the power of x equals ax. Okay? And this is kind of the more complete package right here. This is a more general statement, and this would be kind of a log rule. And as an add-on, you have this a log of a x equals x. So essentially what happens here is that you have an exponential expression in which you have an exponent as a log term. So that basically ends up negating it, or sort of it's an inverse operation. So you end up with x equals x. Okay, now this right here, this property becomes a little bit more relevant when you're dealing with logarithmic equations. But for now, I think what I would like you to take away from this video is this third rule. Okay, with that said, let's go ahead and jump into an actual practice of these logarithmic properties. Okay, so for instance, I have the log base b of x equals y, right? So now we have log of base b x squared, right? We can also express this as 2 log base b x, right? And since we know that the log base b of x equals y, we can also express this as 2y. Okay, so we can circle out answer choice number 2. Okay, that is the answer because we can basically use the exponent rule, in which if you have an exponent inside the parentheses, you can write it outside the log like that. Okay. All right, so let's do the next one. Now here we have, let's use a different color. So we have log of A. Now, if you do not have a base explicitly given, you will assume that the base of this log is 10. Okay? The reason why it's not mentioned is because the convention of logs is that its base is 10. Alright, so we have the log base 10 of a equals x, and the log base 10 of b equals y. So what is the log of a times the square root of b? Now here we have to rewrite that last expression in terms of exponents. So a times, what's the square root of b? It is nothing but b to the 1/2. Okay, we can express this as a sum. So we will write this as the log of a plus the log of b to the 1/2. And since you have an exponent, you can write it in the front. So you're going to have the log of a plus 1/2 the log of b. Okay, and since you know that the log of a is going to be x, we can rewrite this as x plus 1/2 y. Okay, and that would be answer choice number 4. Okay, so you just gotta basically rewrite your logs as products or quotients and make sure that your exponents are written at the front. Okay, the next thing we want to do is problem number 3. Now this is slightly more complex, but again, we're right. We want to write everything in terms of a sum or difference, right? So now here we have the log of this huge expression, or just complicated expression. It's not too big. Y and the square root of z. Okay, so we have a product and a quotient. The very first thing you want to do is make sure you separate your product from the quotient. So what you want to do is basically do x squared y minus, right, the log of the square root of z. The reason I did that is because I can express that quotient as a difference, so I did. And now the next thing I can do is I can say, well, okay, I can express the very first term as a sum. So what I will do is I will write log of x squared plus the log of y. Okay, and then I'm going to tag on my third term, so it's going to be the log of the square root of z. Okay, now here I have exponents, so I can rewrite this, and I will write 2 log of x. Okay, I move the exponent to the front, plus the log of y. Okay, minus 1/2 log of z. Okay, now why did I write 1/2? Because the exponent of that z is going to be 1/2, and so instead of rewriting it again, I just put it in the front. Okay, since I know that the log of x is a, I can rewrite this as 2a, okay, plus the log of b, the log of y is b, so I'm going to write b, plus the log of z is equal to c, so I'm going to write, oops, this is going to be a minus, so that will be minus 1/2 c. Okay, and my answer again is 4. This was a very sort of complicated problem. It's not too bad. All you have to do is just express it as first a difference and then simplify that difference a little more. Okay, so let's go ahead and do 2 more problems. Okay. Alright, so here we have the log of 3 equals a, and the log of 5 equals b. Okay, so how can we write the log of 45 in terms of a and b? Okay, so one thing you can do is try to see if by multiplying you get 45. So what are my factors of 45? Well, I have 9 times 5. Okay, it's very common. Can we express that 3 as a 9? Well, yes, we can. We can express this 9 as a 3 squared times 5. And what do we get here? We get 45, and again here we get 45. So let's express this as the log of 3 squared times 9. Okay, and that will give me 45. And this is nothing but 2 log of 3 plus the log of 9. Okay, and we know that the log of 3 is a, so we can write 2a plus log of 9 is going to be, oh, this was supposed to be a 5 plus the log of 5, which is b. Okay, so that will give us 2a plus b as answer choice number 2. Alright, let's do the last one. Okay, so here we have the log of 5 equals a. How can we express the log of 250 in terms of a? Alright, so one thing we can do is we can say, well, 250, we can say that 250 equals the same thing as writing it as 25 times 10. Okay, can we use our 5? Yes, we can, because 5 squared equals 25 times 10. So this will give us 250. Okay, so now let's rewrite this. Let's say that the log of 250 is also equal to the log of 5 squared times 10. Okay, we can express this as a sum. So we can say that 2 times the log of 5 plus the log of 10 is equal to the log of 250. Alright, so now let's see. At the beginning of this video, I said that if the base is not explicitly given, you will assume that the base of this is 10. Okay, so let's write a 10 right there as my base. Okay, and we can say, okay, well, here this one looks like we cannot simplify, but this one looks very similar to that first rule, which said that the log of base a, okay, a equals 1. Okay, that means that a to the first power equals a. Okay, so that means that we can rewrite that this second term as 2 log of 5 plus 1. Okay, and since we know that the log of 5 is a, we can express this as 2a plus 1. Alright, and so the answer choice, correct answer choice is number 2. Alright, now this video is actually a lot more complicated than the last one. It requires a little bit more of that puzzle thinking, but hopefully this video helps you and you can reference back to it if you ever want to review properties of logarithms. Okay, hopefully I'll see you next time, and good luck.